Now we'll talk about liquid gas equilibrium. It's a condition in which a liquid and its vapor is in equilibrium with each other. A condition or state where the rate of evaporation equals the rate of condensation on a molecular level, such that there is no net vapor liquid interconversion. That's called liquid gas equilibrium. So this is defined by Henry's law. So Henry's law is a chemistry law which states that the mass of a gas which will dissolve into a solution is directly proportional to the partial pressure of that gas above the solution, where C is the molar concentration of the dissolved gas and P is the pressure of the gas over the solution. So this is how the Henry's law. So solubility of a gas in solution increases as the partial pressure of the gas above the solution increases. You can see here the gas solubility increases if the pressure increases. This is referred to as Henry's law. Now I am looking into the concept of equilibrium further. I took a N2O4. It's a colorless frozen N2O4. At room temperature decomposed to brown NO2, nitrogen dioxide. It became brown. At some time the color stops changing and we have a mixture of N2O4 and NO2 equally. Chemical equilibrium is a point at which the rate of the forward reaction is equal to the rate of the reverse reaction. That's called chemical equilibrium. So at that point the concentration of all species are constant. You can see the number of molecules is N2O4, it's this one, and it started changing and there are minimal number of your NO2 formed. At one stage we got an equilibrium where we don't have any changes afterwards. That's referred to as equilibrium state. Now we are looking into equilibrium constant. Chemical equilibrium is a state in which the reactants and products have no net change over time. This is when the forward and reverse reaction occur at equal rates. This state of equilibrium can be described by the equilibrium constant K. A stands for activity of the respective species. So activity on A into activity on C into activity on D divided by activity of A and activity of B. That's referred to as equilibrium constant. This is referred to as molarity. The concentration is molarity and it is written as moles per liter. Now I am looking into the characteristics of chemical equilibrium. The concentration of each of the reactants and the products becomes constant at equilibrium. The rate of the forward reaction is equal to rate of the backward reaction. Now we are looking into law of mass action. Law of mass action states that the rate of the chemical reaction is proportional to the product of active masses of the reactants raised to the power of stoichiometric coefficient of balanced equilibrium. You can see here I got my products. This product is combined to form, this is a reactant. These reactants combine to form multiple products based on a constant. Similarly, these products will return back to this coefficient via a constant K2. This is referred to as stoichiometric coefficients K1 and K2. This is called law of mass action. As I told, law of mass action is defined by the rate constant. So rate constant of forward reaction divided by the rate constant of backward reaction. So this is how your stoichiometric coefficient will be defined.